Hello everybody, this is Hardhik Raju. I'm a graduate student from the Civil Engineering Department at University of Illinois. This is my fourth credit paper presentation, research paper for the course CEE422. I'm presenting life cycle cost analysis as a strategic tool for sustainable construction. This is a research that I'm doing from UIUC, the Department of Civil Engineering. Construction faces growing pressure to be sustainable, but sustainability isn't about environmental responsibility, it's about balanced economic and social factors too. LCCA, as we call life cycle cost analysis, bridges that gap by evaluating total project costs from the start to finish, integrating financial, environmental, and social consideration into one comprehensive environment. Traditional construction focuses only on upfront capital cost. You build to budget and move on. LCCA is fundamentally different. It evaluates the total cost of ownership across the entire project lifespan: construction, operation, maintenance, replacement, and disposal. This long-term perspective reveals hidden opportunities for cost savings and sustainability. This research had five main objectives. First, investigate LCCA principles and methodologies. Second, examine how LCCA integrates with broader sustainability frameworks. Third, evaluates its effectiveness through real-world case studies. Fourth, identifies barriers preventing wider adoption. And fifth, provide actionable recommendations for industry professionals. My literature review revealed three critical findings. First, combining LCCA with life cycle assessment, which quantifies environmental impacts, creates a truly holistic evaluation. Second, high performance materials through initially more expensive consistently deliver 20 to 30% more life cycle savings. Third, barriers exist. Data inconsistencies and difficulty quantifying social benefits limit adoption, but the evidence is compelling. The objectives of this study are simple: to evaluate green design, to provide real examples, to identify barriers, and to examine digital tools that can be helped in easier adoption like building information modeling. Sustainable construction rests on three pillars: economic viability, environmental responsibility, and social equity. LCCA integrates all three. The economic dimension evaluates life cycle costs. The environmental dimension, provided by LCA data, quantifies carbon emissions, energy, water, and waste. The social dimension captures occupant health, community impact, and resilience. Together, they form a complete sustainable framework. We can talk about the first case study of an urban bridge. Let me show you real results. I studied a 20 million urban bridge over a 50-year lifespan. The decision: use high performance concrete instead of standard concrete. Upfront costs are increased by 15%, but maintenance needs dropped by 40%. Overall, the total life cycle cost fell by 20%. That's millions in savings plus greater durability. Next, we come about case study 2, where it involved a LEED certified office building with energy efficient HVAC, advanced lighting tools, and sustainable building envelope. The results were 25% reduction in total life cycle cost and 35% reduction in carbon emissions, which also provided improved occupant comfort. Environmental and economic benefits aligned perfectly in this case. Coming to the third case study, was a residential renovation of adding insulation and solar panels and renewable energy. Upfront investment rose by 18%, but annual energy cost dropped by 30%. Plus, occupants enjoyed better comfort and indoor air quality. Even with intangible social benefits, the case of investments was strong. We shall talk about the methodology now. So, how do we conduct rigorous LCCA? I followed 8 systematic steps: define scope and functional unit, collect comprehensive cost data, classify costs as direct, indirect, or tangible, apply present value discounting, integrate environmental impacts, use multi criteria analysis, and leverage BIM tools and report with validation. This structured approach ensures accuracy and transparency in the methodology. The scope of the project was specified in three stages. The functional unit, entire asset across its lifetime for fair comparisons, and the geographical regulatory factors, local energy sources, waste laws, and what influenced the scope. And the third thing was stakeholder alignment, early discussion with owners, planners, and maintainers, align goals, and improve data quality. Now we move on to the robust data collection system that we used. Data collection is critical. On the cost side, we gather capital costs, operational costs, and maintenance schedules and disposal estimates. On the environmental side, we use life cycle inventory databases like EcoInvent to quantify carbon, energy, and water and wastes. Combining these sources creates a complete picture. Next up, we come with cost classification and discounting. Costs fall into three categories as we spoke previously. Direct costs are tangible capital operations maintenance costs. Indirect costs are environmental externalities monetized via carbon pricing. Intangible benefits include occupant health and community resilience. We then apply present value discounting using 3 to 4% discount rate to convert all future costs to today's dollars. It is important to integrate environmental and social metrics, so we enhance sustainable development by incorporating LCA derived environmental consequences. So we monetize environmental indicators, we and throw light on stakeholder preferences while also considering qualitative scores. Building information modeling revolutionizes LCCA. BIM centralizes costs and sustainability data, provides 3D visualization of life cycle impacts, enables real-time scenario comparison, and fosters stakeholder collaboration. This digital integration dramatically improves analytical accuracy and transparency, which is essential for building confidence in recommendations. Finally, when we come to the key results and insights that we have received, so LCCA reveals compelling economic and environmental impact. Sustainable choices deliver 30 to 40% operational savings, 22% energy efficiency gains, and 35% reduction in embodied carbon. Conclusions and future scope. LCCA is not just accounting, it's a strategic enabler for sustainable construction. Future directions include computational tools with AI and machine learning for real time cost evaluations, which are pretty dynamic. Strong social measures with quantitative benchmarks for community welfare, global standardization for consistent benchmarking, centralized data archives, reducing information gaps, and policy alignment, fostering wider adoption. By adopting LCCA as a standard practice, we equip construction professionals to lead projects delivering economic efficiency, environmental responsibility, and social equity simultaneously. Thank you.